Let's talk about entity transfer in ARENA model. So entity transfer, there are several types of entity transfer. One is you can use connect, which takes only zero delay. So far we use a connect, right, between modules, right? So it does not have any time delay, right? So it has a connection between the modules in graphic way. And also you can use a route, and I already addressed the route module when I taught you the chapter 3, right? 3 and 4. So in route, you can have a delay. You can provide a time delay, right, for as a travel time from the stations to another station, right? And also, so these two actually connect and route both assume that there is no limit on the number in transit at a time. So basically, there are so many vehicles can travel from certain station to the destination. Okay, and the entities have their own feed as well. So in order to, if you have only fixed capacity of the route in the route, like a roadway, then you need to use other like a module, right? So let's consider resource constraint transfer, okay, which has a limit on the total number of entities in transit at a time. And then also entities, in this case, entities still have their own feed, and material handling device especially has a constraint, right, on the or limit on the total number of entities traveling to the another destination, such as transporter involving forklift, truck, cart, wheelchairs, right? Usually this has a limit on the limit, right, on each capacity. So like a vehicle, right? If you look at the car, and basically it cannot have an unlimited number of customers, right, or passengers in a car, right? So that's why. So also you can consider conveyor using the manufacturing facility a lot, right? So conveyor belt. So conveyor has a belt, hook lines, escalator, and so on. So the conveyor has this kind of types. So let's look at this small manufacturing system to consider the resource constraint transfer, okay? And here we have a station receiving the part, okay? And then there are 4 different stations having a machine, so cell 1, cell 2, cell 3, cell 4. And then we have the last station, which is so where last station, and here the whenever part enter this station, it will leave the system. Okay, and it has a circular layout, so it's a more like a, yeah, this is a small manufacturing uh, system or shop floor system having 4 cells. So cell 3 especially having 2 machines, as you can see here, 2 machines, and your one has actually is 20% faster than the old one. And all transfer time, let's assume that 2 minutes, okay, between the cell and then between this arrival station and then cell. Yes, all transfer time is 2 minutes. Okay, and there are 3 separate part types. Interarrival following the arrival interarrival time following this exponential distribution, and then out of 100 out of all types, and then 20% we have 26% of type 1 and 48% of type 2 and 26% of type 3. Okay, and different part type follow different route. That's make us difficult to develop the model. So typical model. So here, if you look at the part type 1 and 2, 3, it has its own processing sequence. So initially part type 1 start by cell 1, cell 2, cell 3, cell 4. And then part type 2 start by cell 1 and also cell 2, cell 4, cell 2, cell 3. Okay, so revisit the cell 2 actually. So and then part type 3 enter the cell 2 first and then cell 1, cell 3. So manufacturing sequence is different between different part types, right? Also the time. So it's a triangular, if the processing time following the triangular distribution, and then each processing time is also different, even at the same cell. All right, and we want to observe utilization of each cell, and then number of entity in the queue, part in the queue, and then cycle time as well. And we want to run the simulation model for 32 hours. So here is the overview of the simulation model. So part arrival. So in order to address 3 different part type arrival, you need to have the one create module with the assign module. So in assign module, you can actually assign the part type. So create module, you can create the entity initially according to the given interval time, which following the exponential distribution, right? And then in assign module, you can actually assign the part type using this part index attribute. So it's following the discrete empirical distribution, as you can see. So 26% of part 1, and then 70, and then 48, additional 48% of part 2. So this is a CDF, right, of this distribution. And then last time is 100%, right? So 26% of the part 3. So part index will have the value of 1, 2, or 3, right? And transfer time is 2 minutes, and then transfer time variable, and hold the transfer time constant of 2 minutes between stations. So in order to do that, you can go to route module and then set the transfer time. You can just type the 2 minutes if you want it, doesn't matter. But in this model, we are going to use a variable, right? Having 2. So this variable, the variable name is transfer time. And then destination will be determined by sequence. And let's talk about the sequence. Before we do that, before we use the sequence, actually, we need to set up the triangular distribution for each part type, right? Well, for each cell. So use the expression data module for processing time as L1. Okay. So also we can use this you can specify this time in the cell sequence. Okay. But I want to let you know how to use the expression array in here. So in the expression array, if you use this cell 1 times, and with the 3 values, and then you can create the 1-dimensional expression. Got it? And these parameters are given by table. So which table? I already give this table, right? So it's very important. Okay. And then here's the distribution, right? SL1. Also, so once you have this expression array, you can use that expression array, okay? Like a set. And here we have an equation to calculate delay time for the older machine and new machine. New machine takes 20% faster than old one, so its speed will be multiplied by 0.8, right? 20% faster than old one. So this is a speed vector. Let's say this is a vector, speed vector, okay? And then this is a 1-dimensional vector variable array, and process time. So this is original machining time, okay? That's cell 3. All right, and also there is a sequence data module to specify the sequence operations of each part type. And different entity types follow the different process plan in this problem. And process plan with automated routing by entity type actually sequence help us, right? Help entity having each own processing plan. And entity follow each own sequence basically, and then this sequence will not use direct connect or route, and so you need to use a sequence data module, specify the sequence for each part type operation and for operations of each part type. Okay, so go to the sequence data module in advanced transfer panel, and define this 3 different plans for each part type, for 3 different part types. Okay, and here if you click this one, and then you can see actually the operation sequence here: cell 1, cell 2, cell 3, cell 4, axis system. Okay, and then here are the assignments for each at each station. All right, and once you have 3 sequences, and then you can create a set of sequences, okay, through the advanced set. So select the other as a type of the set, and then choose and then type all 3 different sequence names here. And you can assign the sequence name in the assign module, right? Like this. So entity.sequence must have the sequence information. So in here, and you can actually assign in this assignment. So this value will directly go to this will be saved in this attribute, right? Whenever entity passes this assign module. So part sequence and index in part index, because part index will have the value between 1 and 3, right? According to the part type, and then if we has 1, and you will get the first sequence plan, right? A sequence operation sequence for the part 1, and then if it has 2, and then you will have a sequence plan for an operation plan for the second part, and so on. So part sequences, we saw this, right? This is a expression set. So here we are calling the expression set using this index information. All right, and then in the route module, you need to use a by sequence option to set up the destination of the travel. Okay, and then in sequence, you have to have the exit station so that after that, each part can leave the system at the end. Okay, so since I will provide the tutorial to develop this model, so you don't need to worry about it. You please develop the model according to the tutorial. Okay, and then submit the model to me by today. Thank you.